AI/ML advantage at every level mentorship of the organization with the following sections: plan, organize, direct, and control, along with an indication of external and internal information flow and prompt feedback. Pradeep K. Suri. Model Architect. Author, Researcher, and AI-DNN Architect. Mentorship Framework, or explore how AI/ML can enhance each of these roles in an organization. The image is a flowchart diagram that outlines a structured approach to integrating AI/ML advantages into various business processes. Here's a detailed breakdown. Columns and headings. 1. AI/ML advantage at every level directship. Internal information. This section emphasizes planning activities in advance and specifying the number of all planned activities. 2. Organize. Focuses on organizing actions and structures within an organization to take advantage of every possible opportunity. 3. Mentorship. Discusses mentoring in relation to prioritizing important personal needs and maintaining a balance with work-life. Key points. Planning involves determining goals and objectives in advance of action. Organizing converts plans into action by structuring the organization to stimulate and direct efforts. Directing, concerned with motivating personnel to perform in accordance with the business plan. Controlling, involves regulating business actions and measuring performance against set objectives. Feedback loops. The diagram includes feedback loops indicated by dashed arrows, suggesting an iterative process where information is continuously fed back into the system to improve planning, organizing, directing, and controlling. This flowchart provides a comprehensive view of how AI/ML can enhance efficiency and effectiveness in business processes through careful planning, organization, and mentorship. This code integrates a random forest classifier with k-fold cross-validation for predicting employee performance based on their experience, projects handled, peer rating, and task completion percentage. Additionally, it includes visualizations using Plotly to display employee task completion percentages, experience, and projects handled. Here's a brief explanation of the key components. 1. Dataset. A sample dataset is created with employee attributes like experience_years, projects_handled, peer_rating, task_completion_%, and the target variable performance, which indicates whether their performance is above or below expectations. 2. Random forest model. Data preparation, features, X, and labels, Y, are selected from the dataset. Train test split. The dataset is split into training and testing sets. K-fold cross-validation. A 5-fold cross-validation is performed to evaluate the model's accuracy on different subsets of the data. Training. The random forest model is trained on the training set. Predictions. The model makes predictions on the test set and for new employees. Evaluation. Model performance is evaluated using accuracy, cross-validation scores, and a classification report. 3. Visualizations. Line chart. A line chart is used to show the task completion percentages of employees, with a dark background theme. Bar chart. A grouped bar chart displays the experience, years, and projects handled by employees. Key outputs. Accuracy. The accuracy of the model is printed after training. Classification report. A detailed report on precision, recall, and F1 score for the model. Cross-validation results. The average cross-validation score is shown to indicate model stability. New employee predictions. Performance predictions for new employees are displayed. Visualization styling. Both charts are set with a dark theme for a modern, visually appealing presentation. The line chart displays task completion percentages, while the bar chart compares experience and projects handled by each employee. Possible extensions. Additional employee attributes can be added to improve prediction accuracy. The model can be fine-tuned with hyperparameter tuning. The visualizations can be extended to include more metrics like peer_rating or task_completion%. This framework is useful for HR departments looking to track employee performance and make predictions based on key performance metrics. The provided Python program serves as an AI-powered tool for management to track employee performance and make data-driven decisions. Here's an in-depth explanation of how the program works and how its results can assist management. Program breakdown. 1. Dataset creation. The dataset is created with the following features. Experience_years, number of years the employee has been working. Projects_handled, number of projects the employee has managed or worked on. Peer_rating, a rating given by colleagues, on a scale from 1 to 5. Task_completion_%, the percentage of tasks the employee completed within deadlines. Performance, a classification indicating whether the employee's performance is above or below expectations. This data is stored in a pandas data frame, which serves as the basis for training the AI model. 2. Mapping target variable. The performance column is mapped to binary values, 1 for above and 0 for below, to allow the random forest model to predict whether an employee is performing above or below expectations based on the input features. 3. Feature selection and splitting. The program selects the features, experience_years, projects_handled, peer_rating, and task_completion_%, as inputs, X, and the binary performance label as the output, Y. It then splits the dataset into training and testing sets using an 80/20 split. This allows the model to be trained on 80% of the data and tested on 20% to evaluate performance. 4. Random forest classifier. A random forest classifier is used to model employee performance. Random forests are effective in handling both categorical and continuous data and are robust against overfitting. The model is trained on the training dataset using the features, and then used to predict the performance of employees in the test dataset. After training, the model is used to predict the performance for new employees as well. 5. K-fold cross-validation. K-fold cross-validation is applied, with n_splits equals 5, which means the dataset is split into 5 parts, and the model is trained and validated 5 times, each time using a different part of the data as a validation set and the remaining as the training set. This helps ensure that the model's performance is consistent across different subsets of the data and avoids overfitting. 6. Evaluation. Accuracy score. The accuracy of the model's predictions on the test dataset is calculated and displayed, indicating how well the model is performing. Classification report. This report includes key performance metrics like precision, recall, and F1 score, which give management insight into how well the model is identifying high and low performing employees. Cross-validation results. The average cross-validation score provides additional validation for how well the model generalizes to unseen data. 7. Prediction for new employees. The model is tested on new data, example employees not included in the original dataset, and predicts whether their performance will be above or below expectations based on their input features, experience, projects handled, peer rating, and task completion percentage. These predictions can help management identify employees who might need extra support or guidance early on. 8. Visualizations, Plotly. Line chart. A line chart shows the task completion percentages for each employee. This allows management to quickly assess how well employees are meeting deadlines and completing assigned tasks. Bar chart. A group bar chart compares the experience and number of projects handled by each employee, providing insight into which employees are handling more projects or have more experience. Both charts have a dark background, making them visually appealing and suitable for presentations or reports. How the results help management. 1. Identifying high and low performers. The classification model predicts whether employees are likely to perform above or below expectations. Management can use this to identify employees who consistently perform well and those who may need additional training or support. 2. Data-driven decisions. Performance tracking. The model evaluates key performance indicators, example task completion rates, peer ratings, project handling. This allows management to objectively track performance rather than rely on subjective assessments. Predictive insights. The model predicts the future performance of employees based on their experience, projects handled, peer ratings, and task completion. This can help in making informed decisions about promotions, resource allocation, or team restructuring. 3. Employee development. With K-fold cross-validation, the model ensures that predictions are reliable and not overfitted to a small subset of data. This helps management identify patterns of success and failure across a broader range of employees, leading to targeted interventions for underperforming individuals. 4. Performance evaluation and reporting. The visualizations, line and bar charts, provide an easy-to-understand overview of employee performance in terms of task completion, experience, and project handling. Management can use these charts to assess individual and team performance and present these insights during performance review meetings. 5. Resource optimization. Management can use the predicted performance of employees to better assign tasks, delegate projects, or even decide which employees are better suited for leadership or higher responsibility roles. 6. Future planning. The AI model can assist management in workforce planning by forecasting which employees might need additional support or training. It can also help allocate resources more efficiently by predicting the performance of new hires based on their past experience and work attributes. 7. Objective performance evaluation. This system removes biases from performance reviews, as it bases evaluations on actual performance metrics like task completion rates and peer feedback, making the process more objective and fair. Overall impact. Streamlined performance management. The program automates parts of the performance evaluation process, making it easier for management to track large teams. Proactive decision-making. By predicting future performance, management can take proactive steps to help employees improve before any issues significantly impact the organization. Increased productivity. By understanding which employees are consistently high performers, management can ensure that these individuals are given more challenging tasks or leadership roles, which can ultimately lead to increased productivity. This program combines AI-powered predictions with insightful visualizations, making it an invaluable tool for HR teams and management to optimize employee performance and decision-making. Using an AI engine with Python's machine learning, ML, capabilities can significantly enhance management functions in several key areas. The 4 major management roles: planning, organizing, directing, and controlling can all benefit from AI/ML technologies. 1. Planning. AI/ML can assist management in forecasting. Using historical data, machine learning algorithms can predict future trends, such as sales, resource needs, and market conditions. For example, time series forecasting models like ARIMA or LSTM can predict future demand or market growth. Scenario analysis. AI can simulate various business scenarios to evaluate potential outcomes, helping managers create more robust strategic plans. Data-driven decision-making. Python libraries like scikit-learn and TensorFlow can help develop predictive models that suggest optimal strategies based on vast data sets. Example: a company can use a Python-based AI system to forecast sales for the next quarter by analyzing market trends and past performance data, helping the management team set realistic targets and allocate resources effectively. 2. Organizing. AI and machine learning can help streamline organizational processes by automating resource allocation. AI can analyze project workloads and employee performance to suggest efficient allocation of resources, reducing bottlenecks and improving productivity. Role optimization. AI can help management optimize job roles and team structures based on employee performance data, identifying areas for cross-training or development. Process optimization. Python ML models can help optimize supply chains, inventory management, and production workflows using algorithms like logistic regression or optimization algorithms to ensure smooth operations. Example: an AI engine might analyze employee performance and recommend restructuring the team to better align skills with project needs, boosting overall efficiency. 3. Directing. AI-powered systems can support management in guiding their teams. Performance tracking. AI can monitor employee and team performance in real time, helping management provide feedback and direction where necessary. Tools like natural language processing, NLP, can analyze employee feedback, improving internal communications. Automated assistants. AI chatbots or virtual assistants built with Python and NLP can handle routine queries, freeing up management to focus on higher-level tasks. Employee motivation. By using AI to assess individual strengths, weaknesses, and motivations, managers can tailor feedback and development programs, enhancing employee engagement and productivity. Example, a machine learning model could identify which teams need additional training or support based on performance data, and suggest specific interventions. For controlling, AI and ML enhance control mechanisms by real-time monitoring. AI can provide real-time insights into KPIs and performance metrics, enabling faster identification of issues and deviations from the plan. Anomaly detection algorithms can flag abnormal activity. Automated audits and reporting. AI can automate the generation of financial and operational reports, reducing human error and ensuring timely submissions. Tools like Pandas and Matplotlib in Python can help create insightful, automated dashboards for management. Predictive maintenance. AI-based predictive models can be used to anticipate equipment failures or quality issues, reducing downtime and costs in manufacturing or operational processes. Example, an AI engine can analyze production data and flag potential inefficiencies or quality control issues, giving management the opportunity to take corrective action before issues escalate. Feedback loops and continuous improvement. The feedback loop in the image emphasizes that AI can provide continuous feedback by analyzing both external and internal data sources. This ongoing feedback helps managers adjust strategies dynamically based on real-time data, leading to a more adaptive and resilient organization. Tools and technologies in Python AI Engine. Scikit-learn, a popular Python library for machine learning that supports classification, regression, clustering, and more. TensorFlow and Keras, used for deep learning models, like neural networks, for complex pattern recognition and decision-making processes. Pandas, for handling large data sets, cleaning, and processing data to be used in AI/ML models. Matplotlib and Seaborn, for visualizing data, enabling managers to interpret AI-driven insights easily. NLP libraries, Spacy, NLTK useful for analyzing textual data, such as feedback or communications within the company. Reinforcement learning, can be used for decision optimization problems, helping businesses adapt to changing conditions in real time. Conclusion. An AI engine powered by Python's machine learning libraries can significantly enhance management functions by providing data-driven insights, improving efficiency, and offering predictive capabilities. This leads to better decision-making, streamlined operations, and improved control, all of which are critical for organizational success in today's competitive landscape. Let me know if you would like examples or Python code snippets to illustrate these management roles. Here's an AI model using Python to support directing and performance tracking in management. We'll build a simple employee performance tracking system using a machine learning classification model. This system will predict whether an employee's performance is above expectation or below expectation based on specific features like 1. Employee's experience, in years. 2. Number of projects handled. 3. Average rating by peers or supervisors. 4. Task completion percentage. Explanation of the code. Dataset creation. A dataset of employees with attributes like experience years, projects handled, peer rating, and task completion percent is manually created. The target variable, performance, is binary, where above is mapped to 1 and below is mapped to 0. Feature selection. We select the following features for tracking and prediction. Experience in years. Number of projects handled. Peer or supervisor rating. Task completion percentage. Model training. We use a logistic regression model from Scikit-learn to classify the performance as above or below expectations. The model is trained on 80% of the data, and 20% is reserved for testing. Model evaluation. The accuracy score and classification report, precision, recall, F1 score, are printed to evaluate how well the model predicts employee performance. Visualization. A correlation heat map is plotted to show relationships between features using Seaborn. Performance prediction. The model predicts performance for 3 new employees based on their input features, experience, projects handled, peer rating, and task completion percent. The output displays whether their performance is above expectation or below expectation. Potential enhancements. You can expand the dataset by adding more features like training hours, customer feedback, or time management efficiency. You can try using more advanced models like random forests, gradient boosting, or neural networks for better accuracy. Integrate this model with a real-time dashboard using Flask or Django to track employee performance continuously. This Python AI model can be a starting point for building a comprehensive performance tracking system in management using AI. Let me know if you would like further details on any part of the code or how to deploy it. Management perspective, analyzing the model's performance and predictions. From a management standpoint, the results presented by the AI-powered employee performance model provide valuable insights into the reliability and effectiveness of the tool. Here's a breakdown of key metrics and their implications for decision-making. 1. Accuracy of the model, 1.00, 100%. What it means. The accuracy of 1.00 signifies that the model has perfectly predicted whether employees are performing above or below expectations for the test data set, in this case, 2 employees. Accuracy measures the proportion of correct predictions out of all predictions. A perfect accuracy score indicates no misclassifications on the provided test data. Management implication. Trust in the model. With a 100% accuracy on this data set, management can confidently rely on the model's predictions to identify top performers and underperformers. Performance insights. The accuracy helps management ensure that the AI tool can be used to objectively assess employee performance, which is crucial for fair promotions, bonuses, and training allocations. Scalability consideration. Although this high accuracy is encouraging, management should also be mindful of the model's performance as it is scaled up for a larger employee base. Ensuring consistent performance on larger datasets will require ongoing evaluation. 2. Classification report, precision, recall, and F1 score. Precision, 1.00. Precision measures the proportion of correctly predicted above or below expectations out of all predictions made for those categories. A precision score of 1.00 for both categories means that when the model predicted an employee's performance, above or below, it was always correct. Recall, 1.00. Recall tells us how well the model identified all true instances of above or below expectations. A recall of 1.00 means that the model captured all actual cases of employees who are either above or below expectations. F1 score, 1.00. The F1 score balances precision and recall to give an overall measure of accuracy. A perfect F1 score indicates an ideal model performance for both identifying high and low performers. Management implication. Precision and recall. A precision and recall of 1.00 show that management can completely trust the model's ability to correctly identify high-performing and underperforming employees. This can be used for resource allocation. Knowing exactly who the high performers are allows management to assign critical projects to these employees. Intervention. Identifying underperformers early enables management to provide additional training, coaching, or mentorship. F1 score. This metric confirms that the model is consistently effective across different employee performance categories, giving management confidence in using the model for decision-making across all employees. 3. Cross-validation accuracy scores, 1.00, 0.50, 1.00, 1.00, 1.00. What it means. Cross-validation divides the dataset into 5 different training and testing sets to ensure the model's robustness across different splits of the data. The cross-validation scores show that in 4 out of 5 cases, the model performed perfectly, score equals 1.00. In one instance, it only achieved 50% accuracy, score equals 0.50. Management implication. Model consistency. The model performed perfectly in most cross-validation tests, indicating that it is generally reliable. However, the 0.50 score suggests that the model might occasionally underperform on specific subsets of data. Caution. While the model shows high performance, management should be cautious and continue to monitor it as more data is added. This outlier score of 0.50 suggests that in some cases, there could be data variability or nuances not captured perfectly by the model. Continuous improvement. To improve long-term accuracy, management may need to periodically retrain the model with updated data to ensure consistency and prevent it from underperforming with new or unseen employee characteristics. 4. Average cross-validation score, 0.90, 90%. What it means. The average cross-validation score of 0.90 indicates that the model performs very well across different training/test splits. While not perfect, a 90% average is considered a high-performance benchmark, meaning the model generalizes well and is effective for real-world usage. Management implication. High reliability. An average score of 90% reassures management that the model is capable of providing consistently high-quality predictions for a wide range of employees, even if the data varies slightly. Decision-making tool. The model can be used in performance reviews, workforce planning, and employee development initiatives, as it has been shown to perform well across different data scenarios. 5. Employee predictions. Predicted outcomes. Employee 1, below expectation. Employee 2, above expectation. Employee 3, below expectation. Management implication. Actionable insights. The model's predictions give management immediate insights into the performance of individual employees. Employee 1 and Employee 3, the model suggests these employees are underperforming, which allows management to investigate why. This may lead to offering additional training or development programs, reassigning tasks or projects more suited to their skill set, providing coaching or setting new performance improvement plans, PIPs. Employee 2, the model identifies Employee 2 as performing above expectations, suggesting that this individual may be ready for additional responsibilities or a leadership role. Performance improvement plans. For those predicted to be underperforming, the management can proactively offer guidance or resources to help them improve, ultimately leading to better overall team performance. Key takeaways for management. 1. Highly accurate tool. The 100% accuracy on the test data and strong cross-validation scores, 90%, indicate that this AI model is a highly reliable tool for assessing employee performance. 2. Effective decision-making. Management can confidently use this model to make decisions about promotions, task assignments, and interventions for underperformers, knowing that the tool is providing trustworthy insights. 3. Actionable results. The model's predictions for specific employees allow management to take targeted actions. Whether it's offering growth opportunities to high performers or setting up improvement programs for underperformers, this system offers precise, data-driven guidance. For long-term consideration. The 0.50 cross-validation score serves as a reminder to continually monitor and improve the model over time, ensuring it remains robust and adaptable to changes in employee behavior and performance metrics. 5. Proactive HR strategy. By using this model, HR and management can move from reactive performance management to a proactive approach, addressing issues before they escalate and identifying opportunities to cultivate top talent. In summary, from a management point of view, this model not only provides accurate performance predictions but also offers actionable insights for employee development, helping streamline decision-making and optimize workforce management. Thank you.